I'm going to present a collaborative educational effort between Oregon State University Wood Science and Engineering and the School of Architecture and Environment at U of O. So this is a collaborative, interdisciplinary, and interinstitutional class that Nancy Tang and I have been teaching since 2017. And really a relatively recent small ARES grant helped us develop it to the next step, that was a design and build studio. So the main goal of this class is to expose students from different backgrounds, and namely wood science students, engineering students from OSU, and architecture students from U of O, to integrated design approaches, which I think you all agreed are quite important for the mass timber industry, and expose them to early collaboration in this multidisciplinary setting. So they're basically embodying the three roles of manufacturers, fabricators, engineers, and architects in an integrated design team. In the recent years, we also focused a lot on circular economy design strategies. And so if you're curious, this is our website. And as I said, we have projects since 2017, but with these last 3 years, we were able to also prototype and build small structures and test them, which I think was very beneficial for the learning experience and also for our scholarly outcomes from this class. So the approach that we use is really merging top-down design approaches, considering the program, design, user requirements, building performance requirements, with bottom-up approaches that consider the construction system. So material properties, connections, fabricability, constructability. And in this way, all these different expertise are engaged at the same time. And the goal is to develop a kit of parts, so a limited number of parts that allow to, with this modularity, to obtain different variations. So it's modular but flexible, and able to be to enable fast assembly, disassembly, and reuse. During the term, the students are exposed to different case studies and test and prototype small models from these case studies, develop sort of IKEA manuals from these precedents. And the class really has to be managed through a robust, structured collaboration and communication platform. So we use online collaborative platforms and communication. We are into separate sites, but also we try to integrate both digital and material works. So parametric design and digital fabrication, and also physical prototyping and testing. So these are some examples of the last 2 iterations of this class. The other interesting aspect is that another partnership has been established with U of O's Sustainable City Years program, which pair classes with local communities and cities. So we have real clients for our projects. And for the 2023, we partnered with the city of Salem. They were interested in developing seasonal canopies for a park. And so we looked at different examples of reciprocal frame systems. And this is the So the image on the at the center top is the Kengokuma's Geikumka museum's roof, and students changed a little bit that system and adapted to their need and constraints, because they had very clear constraints also for fabrication. And they also changed the connection system from an half-lap notch to a tenon and mortise connection. And then all the parts were fine-tuned for this simple arched canopy with, as you see, a very limited number of variations of the parts that were eventually fabricated and so CNC'd and assembled with consideration about pre-assembly and then installation on site. Last year's project, so our client was the city of Silverton, and they were interested in a versatile system for different types of, so for buildings for different applications, including emergency shelters. So we analyzed different, basically a type of cassette, or if you want a stretch skin panel, because we use plywood as the skin, the external skin, for wall, floors, and roof panels. And a lot of attention was in prototyping and testing the connection systems between all these parts. As you imagine, designing them as reversible was quite a challenge. And this is the fabrication process. Students developed their IKEA manual for all the parts and assembly, and this is an image during the construction. Some of the big learning outcomes come from challenges, including the importance of fabrication tolerances, both during installation and then for the final structural performance. The trade-offs, the important the challenges of at the same time allowing reversibility, but also stiffness of the connections. If you see carefully, you see that so the central parts of the arch sag after we remove the temporary supports. And then also allowing for design flexibility while keeping the system with relatively limited number of pieces. And finally, also the integration of the structural system with building enclosure. So students learn a lot of not only hard skills, but also a lot of soft skills that are quite important for the industry. Interdisciplinary communication and collaboration and problem solving. And we Structure also learn a lot through this process, and we were able also to produce some scholarly output, so journal papers, conference papers, and presentation. The last one presented at the World Conference of Timber Engineering and the International Conference of Architecture and Structures. And so we want to acknowledge, of course, ARS for the small grant. Nancy and I were worked together with one of our previous PhD students, Namyu Kan, who is in the audience, for this grant. And also we are, of course, grateful to TDI for always helping us with the fabrication and construction, and UofO Sustainable City Year program, and all the reviewers during the years have helped us during the critiques. And yes, these are some of the publications coming up from this effort. And thank you, everybody.